Hello, Assalamu alaikum. My name is Mohammad Uzair Akbar, 20TE16. Today we are going to discuss about our lab 7 and 8 frequency analysis of signals. So we start with our task 1, which we have assigned values for x values, and also we have a sampling frequency of 20 kilohertz, 20 kilo sample per second, and we need to plot these frequencies over after removing 5k. So first of all, we plot the simple graph for this, and we need to run this over MATLAB, and we have a value. We need to first save this, and now when we run this, we get a graph like this shown for the simple values for sampling frequency and the values for time, different values for time. So now when we apply after removing frequencies above 5 kilohertz, so MATLAB cannot give result in a better way, so we will get on it on Octave online. So we have a cut of frequency. We can see that which we were given 5000 hertz, and we have Butterworth formula for this, and which is equal to sampling frequency by 2. So we have plotted this, we have applied a filter, and we have plotted this filter signal, and which give us a value like this, which is shown to be like this after 5000 cutoff frequency. So we filter signal, and when we can see the peak of this signal by plotting this, and when we change the cutoff frequency from 5000 to 7000, so we can see the difference in the peak of this value. We can see the peak, it was about 1. Now we can see that it is given more up and down as well. So moving on toward the task 2, we have given we need to run a music file. So first we need to get instructions, and first of all we will get to calculate about the DFT, and we have sampling frequencies. We need to remove upper and below frequencies from FF by 4. So first of all we need to give command to it, which is given for the audio files, audio running files. So we have X of FFT, and we have assigned values for N, and similarly to plot the first music, and now we have cut frequency as was discussed before, that sampling frequency by 4. Similarly, the cutoff frequency is shown to be, we need to filter the audio, and we need to apply inverse Fourier fast Fourier transform, and length of the, when we pause it, the length is these all are formulas when we simply run our sound. So we add it, and we have a magnitude spectrum like this, which is shown to be, we have a gap in the frequency that above 4 these are removed. So sampling frequency as was instructed. So it is this is the simple magnitude spectrum of this lab, and now we have to plot the second one, and we need to see that we have a we have a cutoff frequency on the sample frequency and 4 FS by 4, and we need to run the second sound. When we add it, we need to add the second sound of this, and we have a difference in the sound magnitude spectrum from the first one, and there is this which is shown clearly. So moving on toward the last 8. So first task, we need to plot time domain along with this magnitude response. We need to plot using windowing, Hamming, Henning, and Blacksman. So we have a code H values H0, H. We have values like H0, H1, H2, H3, and so on. So we have values in the negative as well, as H1 is equal to H minus 1, and H2 is equal to H minus 2. So we have n value for n value is 1024. When we plot this, we filter impulse response is shown, but we need to get the required result, which is which MATLAB can't give us. So we will use Octave Online. So similarly, we can see that Octave Online gives the same result above as in MATLAB, but now this is our required result for this lab we needed. So similarly, when we plotted this, and we use these techniques, and now n value for n is equal to 512. So we have given values to h, and which were assigned in the task, and we have first of all we put value formula for Hamming window, and then we put formula for Hanning window, then Blacksman. Similarly, we have a curve shown in the figure, above is for Hamming, second one is Hanning, and Blacksman, third one is Blacksman. So moving on toward the task 2, we have sampling frequency and time duration, and values for x, where x1, x2, x3 combined gives x. And similarly, when we plot these on MATLAB, and we need to run this with the figure, we need to plot this on the MATLAB, and value for n is length x. So similarly, when we plot, we get magnitude response. First of all, we get signal in time domain. The second one is magnitude spectrum, and the third is magnitude response of the this task, these values. So moving on, we need to run three music now. So we two music now, sorry. When we run these values over, we have given instructions as per discussed before, that we need to write when we have to run audio on MATLAB. So we have given cutoff frequency of 500 hertz, and cutoff high frequency. First of all, low frequency is 500, and cutoff high frequency is 5000. And we need to apply Butterworth filter for this low and high frequency. So we can run this by adding this on saving. We save it, and now we will add music of the file is there. We select the music, and now we run this. So music 1 is added to this, and you can see that this is our this code. This is our code when we have to remove low frequency using Butterworth, and high frequency using Butterworth filter. And we have sound value x to FFS, sampling frequency, and similarly we have pause length over fs plus 1. Thanks for this today lab. We will join you in the next lab, inshallah. Take care. Allah Hafiz.